In this demo, we will take a close look at the requirements tracing functionality in Teamscale. To this end, we will walk through the following 3 scenarios. First, we will learn how project managers can get insights into ongoing requirements activities. Second, we will see how quality engineers can identify anomalies in verification activities. And third, we will experience how developers and reviewers can keep code and requirements in sync during development. So let's get started. In this demo, our requirements management tool is Polarion, but Teamscale supports other requirements management tools as well. Please refer to the online documentation for more information. This is our example requirements specification. We are building a data structure library and are currently working on the requirements for the stack. Let me briefly explain what you see here. We have 2 sections, one for the functional requirements and one where we already specified some tests. There are 7 requirements denoted by this little icon on the left, each of which has a specific ID. For instance, the first requirement has the ID DP544. The requirements have different states. Some are in draft, some are reviewed, one requirement has been approved. We also specified 2 test cases. And when we look at the properties of a test case, we see that it verifies one of the requirements. So there are relationships between the different items in the specification. Test cases, as well as any other items in such a specification, also have an ID. So this is our requirement specification. We will use this specification throughout our demo. In the first scenario, we will learn how project managers can get insights into ongoing requirements activities. We're starting out on the dashboard perspective in Teamscale. For this demo, I'm assuming you're already familiar with the basic concepts in Teamscale and know what a dashboard is. Here we now have an overview of metrics and trends about our captured requirements. So we see for our software system, for instance, how many requirements we have and in which status these requirements are over time. And this helps us to identify, for instance, if there are any requirements that are stale in review. And we are able to identify requirements with oddities. For instance, in our case, we watch out for requirements without acceptance criteria. And here we are able to define thresholds so that we can assess the different metrics, assign different colors, and so on. And we have historical data, which allows us to look at trends and understand if we are on track over time. Now the idea is to have a common dashboard where we see metrics and trends for requirements together with other code quality KPIs for our software. So our goal is to provide a holistic picture of the quality of all artifacts here, from requirements to code and tests, all in a single place. And combining these aspects gives us more context for the data and allows us to draw better conclusions and make more informed decisions. That is what we call software intelligence. Now, as you know, you can freely configure dashboards in Teamscale with different kinds of widgets. And this is no different for requirements and other specification items. So you can create your own personalized overview dashboards that are tailored to your questions and needs. Next, let's explore where the visualized data actually comes from. To that end, we switch to the requirements tracing perspective. Let me briefly break this down for you. At the top, we have a field where we can enter a query. It is currently empty. At the bottom, we see the result of the query we entered at the top. Right now, since the query is empty, we see all specification items. Now the data source for this query is the Polarion specification we saw a minute ago. For information about how to configure which requirement specification Teamscale reads, refer to the Teamscale documentation. In Teamscale, we use the term specification items to denote requirements and other items of your specification. This might be, for instance, the test cases we saw in Polarion. And for each specification item, we see its ID, subject, status, and assignee. There also is a little indicator for the type of the item. Here, for instance, we have requirements and tests. We can now formulate queries over these items. For instance, if we only want to see requirements, we can write type equals software requirement. And if we only want to see the approved requirements, we can add and status equals approved. We could even formulate more complicated queries, for example, to find requirements that have been in review for a long time. Let's save this query we give it the name requirements/approved. This adds the query to the sidebar on the right. Note that the slash we used served as a folder separator here. Now we have a couple of queries on the right sidebar. You can use any of these queries as data source on the dashboard. Now let's look at some of these items more closely. When we select an item, we get to see its details. We see the title together with an external link. This link lets you open this item directly in your requirements management tool. Other information we see here includes metadata, like the creator or when the requirement was last updated. The description provides more details about the item. In the linked items section, we get all the related specification items. As you saw, we had test cases in addition to the requirements. And this requirement is verified by the test case DP547. We can now simply follow the link and see the test case itself. And again, we see the details of this test case here. I will explain this tracing section in a third scenario. So this concludes the first scenario. We've seen how to get insights about the captured requirements and other specification items, how to create and view metrics and trends about these items on a dashboard together with other quality indicators to provide a holistic picture of the quality of the software engineering artifacts. And we looked at the representation of requirements and other specification items in Teamscale, including the details and relationships between them. In the second scenario, we will see how quality engineers can identify anomalies in verification activities. We start on the requirements tracing perspective. Remember that we can enter a query at the top to filter on any subset of requirements or other specification items we like. Right now, we just leave the query empty, which gives us all specification items. Be aware that these might be many in your case. Now we have several tabs here. Currently, we are on the specification items tab that simply contains the list of the items we selected. To investigate how our software is verified, we switch to the second tab, Verification Matrix. On this tab, as the name suggests, we get the verification matrix for the selected specification items. The verification matrix is a standard means in requirements tracing, but let me take you through this step by step. The columns of this matrix are the specification items we selected by virtue of the query at the top. Right now, these are all specification items because we left the query empty. But if we select one of the queries in the right sidebar, you see how the columns change on the fly. So we can set the scope to what we actually are interested in. For instance, if we only want to see the requirements or only approved requirements and so on. It makes sense to create a query for the specification items your team is responsible for. Now, traditionally, verification matrices are often large, clumsy spreadsheets where the data has to be entered manually. In contrast, Teamscale shows the verification matrix on demand and for any scope you like. But let's look at the whole matrix again. So each column corresponds to a specification item. The rows of the matrix are the tests. Teamscale found these tests by analyzing the source code for common test frameworks such as G-Test. We will not go into the details of Teamscale's test framework detection in this demo. For more information on this topic, please refer to the Teamscale documentation. We currently have two tests here, stack tests push and stack tests pop. Let's follow the link. As you can see, the two tests are here in this simple C file. We have one test for push, one test for pop. The tests in this example are implemented with the G-Test framework. In the comment above the tests, you see references to specification items. These references are very important. They tell Teamscale that this test function is related to the reference specification items, and thus they enable the traceability between this code and the referenced items, which is exactly what we see on the verification matrix. There are other ways how to link between code and specification items, but we will explain them in a subsequent demo. Above the test for push, we reference the requirements DP541 and DP544. And as you can see, if we hover over these references, Teamscale is aware that these are specification items it knows, and it provides us with a quick preview of these items. The third reference here, DP548, as well as the reference above the POP test, DP547, link to a test case specification. Here, a verification engineer already provided a blueprint that determines how to test the push and pop functions. This is just to illustrate that tracing works with any specification item you have, not just requirements. In your project, there might be just one of them or completely different ones. Now that we've seen the actual test functions, let's go back to the verification matrix. We have the specification items in the columns and the tests in the rows. Now for each test that links to a specification item, there is an entry in this matrix. The other ones are empty. Traditionally, the entries in a verification matrix are just check marks. In Teamscale, you get more information. Not only do you see that there is a connection between a test and a requirement or a different specification item, but you also see the latest result of this test. That way, you can immediately spot tests that are failing or have been skipped and should contribute to your verification story. As quality engineers, we should watch out for such tests, as they indicate a gap in the verification of our software. Let's take an example. If we hover over an entry for the push test, we see that it was skipped when executed on Linux, and it failed on Mac OS. In contrast, the pop test ran successfully on both platforms. Notice that you can select which test results to show in the matrix using the chooser at the top right. For instance, only Mac OS or only Linux. We will not go into details how to get test results into Teamscale in this demo. Please refer to the documentation or reach out to us directly. Let me also quickly mention that you can click an entry to get more detailed information about the test execution history, as well as a quick view of the corresponding test code. The last piece of the verification matrix I want to explain are the column and the row marked with the sigma. These simply sum up the single entries across a row or column. Underneath each specification item, we see how many tests reference this item. Simply speaking, this answers how many tests verify a requirement. As quality engineers, we want to look for zeros here. Those might be a problem, indicating that a requirement is not verified by any test. Next to each test, we see how many specification items the test references. Again, in simple words, this tells us how many requirements the test claims to verify. As a quality engineer, we might want to scrutinize tests that claim to verify a large number of requirements, indicating that these tests are not really specific. So this is the verification matrix. For the sake of completeness, let's quickly glimpse at the third tab here, code references. This provides a very similar view to the verification matrix with one fundamental difference. The rows are not tests, but any other location in the source code where Teamscale found a reference to a requirement or other specification item. The verification matrix focuses specifically on tests because it is the primary means to prove that the requirements have been tested thoroughly. We don't want to have any other code there. In contrast, the code references allow to trace between all other code and specification items. For instance, sometimes it might be useful to link to the corresponding requirement when implementing an algorithm. Such a link would show up here. In general, we would suggest not to clutter all your code with references to requirements. There are other means of marking which code implements which requirements. We will cover these in a subsequent demo. This concludes the second scenario. We've seen how quality engineers can identify anomalies in verification activities by investigating the verification matrix for anything odd, how to filter the verification matrix to the specification items you're interested in, how the verification matrix in Teamscale is made up and what information it shows, and how to find potential problems, including requirements without tests, tests that verify too many requirements, and tests that should verify requirements but have been failing or skipped for a longer period of time. In the third scenario, we will look at how Teamscale supports us in keeping our requirements in our code up to date when we do actual development. To that end, let us assume we are a developer and we have been assigned the task to write tests for the stack requirements. And we start by implementing a test for peeking at the topmost object of the stack, that is, requirement DP539. As we have seen before, we already have two tests here in this simple C file. Our task is to write a test for the peek function. So let's open this file and write the test. I'm using a script to add the test function, which also takes care of committing and pushing the changes. But let's look at each step. We have a new test here for the peek function. And very importantly, we added a reference to the requirement DP539, thus letting Teamscale know that this test verifies the requirement. Okay, so let's now look at our merge request. We have a merge request in GitLab for verifying the stack requirements. And at the very top, you see this Teamscale logo together with two badges. The first badge lets you know how many quality problems Teamscale found in your merge request. The second badge shows the number of specification items that are impacted by the code changes in this merge request. In order to explain what this means, let's follow the link back to Teamscale. This is the corresponding merge request view in Teamscale. Fundamentally, it is the place where you see the impact of your changes in this merge request on the quality of your code base. For this demo, we want to focus on the specification items. This table shows you a list of the specification items that are impacted by any changes you made to the source code. Before merging the changes, it is paramount to make sure that the code is still in sync with the impacted specification items. Traditionally, that is not an easy task. The reason for this is that specifications can get really large and there can be many specifications, making it really hard to locate the right place just based on the number of modified source code files. Teamscale makes this really easy because all necessary information is conveniently accessible in a single place. As a reviewer, you can simply go through these items one by one, as in a review checklist, and make sure it all matches up. In our case, we should look at the requirement DP539, and the reason for this is that Teamscale found a new reference to this requirement from the test function stackTestPeek, which is exactly the function we just added. Remember that all that is needed to get this checklist entry is the reference to the requirement in the comment of the test function. Very simple and very lightweight. From here, we can directly navigate to the requirement and to the corresponding code, and in this case, make sure that the test correctly verifies the requirement. Now let's look at what happens when we modify existing code. To that end, we go back to our test file and modify the pop test. Right now, an assertion is commented out, so let's fix that. Again, we use a script to make that modification and commit and push the changes. As you can see, we now have two assertions and an explaining comment. Let's look what happens to the merge request view in Teamscale. We got a second entry in our review checklist that lets us know that the test stack test pop has been modified. And since it references the specification item DP547, we shall make sure that specification and code are still in sync after that modification. If they are not in sync, the code change might need rework, or the reference specification item needs to be updated. This can happen especially in innovative projects where you learn about the feasibility of the specified functionality, for instance, while you are prototyping. Finally, let's see what happens if we remove a reference. So in our test file, we remove two of the references for the push test, DP541 and DP544. As you probably expected, our checklist got 2 new entries, one for each removed reference. So even though we lost the information about the 2 requirements in our code, we still have the chance to review that removing the references was actually correct, and for which requirements we now have less tests that verify them. Let us look at one more thing here. In the beginning, we added a test for requirement DP539. Let's open this requirement. And let us now expand the tracing section. There are 2 tabs here, Code References and Test Executions. On the Code References tab, we see all references from the source code that point to this requirement. Currently, there are 2. One is a test, namely the test we have just written, and the other one is not. On the Test Executions tab, we see the results of the tests that point to this requirement. Currently, there are none, since we just wrote our test and did not yet execute it. Let's now execute our test suite and upload the test results to Teamscale. If we now refresh the page, we see the test result for the peak test. And if we go back to our verification matrix, we see that we now have 3 tests here, including peak. Also, our tests on macOS were now executed successfully. And this concludes the 3rd scenario. We've seen how Teamscale supports us in keeping our requirements and our code up to date when we do actual development. How to reference requirements and other specification items from the source code. How Teamscale tracks modifications to the code or the references and captures them in the impacted specification items table. And how developers and reviewers can use this table as a review checklist with 1 entry per specification item that is relevant in the context of the performed changes. And Teamscale adds a link and a summary of this checklist directly into your merge request. Thank you for watching. Please reach out to us for any further questions. We are happy to help you set up Teamscale for your project.